Hey guys, welcome to part two of day one itself, and we'll continue doing PyTorch. By the way, if you see this current VS Code PyTorch subject matter expert repository, I've actually uploaded the same on GitHub. So y'all will have access to the exact content of this course. It's just me reading through this content and instructing you and showing you stuff as I will basically make this with the help of AI. That's basically what I'm doing so that even you will be able to follow through and will be able to just copy paste the code if you get confused anywhere, right? So let's get started. So we did finish enumerate yesterday, right? We're going to do the spread operator. So for example, we have a bunch of numbers like this. We have got 1, 2, 3, 4, 5. Okay, maybe that was 45 or 44 or whatever, right? And then you want to spread it out over a large group. So for every this thing you wanna do it. The best way. Sorry, my bad. Just give me a sec. Yeah, there we go. So what we're gonna do is let's say number 2, okay, is equal to 5, 6, 7, 8, okay, comma numbers. So if you see this and we just run it. Oh, wait, sorry. My mistake. So the three dots are a spread operator in JavaScript, and it's not the same in Python. So over here, what you got to do is you got to do star. Look at it over here. How you do it? There you. Oopsie daisy. I meant numbers too. There we go. There we go. Right. We can't do dot dot dot. Spread operator is really commonly used in JavaScript, so people get really confused, me too. So I would always remember Python is very slightly different. It's got the star, right? So here is an example, def a plus b plus c, and he has given the values, and he's done it for every result, right? Result is equal to compute stack star of values, print result. So you can then basically, unpack it over there. So now we will also go over an example. Okay. I think what he has done over here is he makes a dictionary where learning rate is this and batch size is this. Then he basically unpacks the config. And the way he unpacks dictionary is basically like this. This is how he does it, right? You can do it in a function call as well. Okay. I think I understood what he's trying to demonstrate over here. He's basically unpacking the dictionary. So dictionary is 2 stars. So let's actually make a dictionary. So we call this as dict config. Okay, dict config is equal to this. And here we have LR, which stands for learning rate. So we can have that as 0.01. It's usually really tiny. It's like really, really tiny. Here he's given 0.01. So you could go much lower. And this you would keep changing. We'll have batch size. Oops. This we could usually go to 32. Yeah. And then we will have dix expanded config is equal to star dict config comma device. Okay, he got CUDA. And also he has epochs. Okay. And here the epochs, let's put it as 100. Okay. And finally, let's also add one more thing. Let's actually overwrite LR and let's see if that works. Right? So learning rate is now 90. So now let's see if this works. So if you look at this, learning rate is obscenely high. It has updated the value of the previous learning rate, if you can see. But it's updated right there in the same dictionary, as you can see. So the 2 stars are used. Will 1 star work? I don't think so. It will not work. You have to do it with 2 stars if you're expanding the dictionary. Okay? So now that we have this, we are going to go to the next part, which is unpacking dictionaries and doing lambda functions. Okay. Lambda functions are also pretty simple. You just they're just a way of indicating stuff, right? It's like a inline single line function. It's a bit tricky to understand, but we will break it down a bit by bit. Okay. So let's say we have x is equal to 12. Okay. So now square is equal to lambda x such that x star star 2. Maybe we can do x star star 2 plus 2. What do you expect? So I expect 146 to be the answer for this, right? Now we can be like square of x. Okay. Now this we can put it as x1. We can put whatever value. Okay, cool number. That's a better way to explain. So square of cool number. There we go. Okay, so we got this is a single line function, but now let's say we had cool numbers which were 22, 10, 3, 3, 2 or something. Yeah. Now we could do the same thing. Yeah. Now let's see what we get. Unsupported list. So what do we do in this case? A very simple thing. You could expand it. Will that work? No. You can do a for loop though. Or you can write another lambda function for that, right? Or you can even map. I completely forgot. You can map. I don't think you should write another lambda function. It was a bad idea. You basically map. So map is another very important function. Let's actually just go for it. Or what you can do is um I mean I would ideally I would actually make it a lambda function. Okay. So I would just write here square number. I will write here square nose. Okay. Square nose is equal to lambda of x such that it does square of x. So what am I trying to do here? I'm trying to basically do a lambda function of a lambda function, which is uh, sort of stupid, which is sort of stupid. But let me tell you this. Okay. Sorry, I got really distracted and I came back. But basically, lambda functions are basically inline functions. You could do it something like this, where you basically define the function within itself. And if you want to use a spread operator, then you have to actually indicate the spread operator and use it with the spread operator. Otherwise, it won't work. Okay, so that's basically how lambda functions work. There's also math. So let me actually just show you what is math very quickly. So let's say you have a array and that array is filled with 1, 2, 3, 4, 5. And what you want to do is you want to map this. You have a function. Let's say you have a very cool function called, let's call it add add 5. So the function's name is add 5. So what does this do? It basically takes an x, it returns 5. Okay. So this is a function. So what you could do is you could map it. So you could print, okay, because what map does is it will take an iterable, so it will take a function and then an iterable, which is an array, right? So this will, can you guess what it will give? It will just give all of these numbers shifted by 5. So if you do that, oh, it's giving you a map object. So the best way to convert is you'll have to convert the iterable into a list and then you would get your answer there. So that's what map does. There are different ways to use lambda functions. Lambda is the same thing. If I were to write an inline lambda function, then it would be just taking, uh, as simple as, we could do it something like this. Add 6 is equal to lambda x such that x plus 6. Okay, so I think this has prompted it for me already. And yeah, you could also do the same thing again, and you would get the mapped part over there very quickly. And Lambda just makes this whole thing much simpler and inline. That's the biggest advantage of using a Lambda. Now that we're done with Lambda functions, we'll go very quickly over what are decorators. So decorators are, properties that are used to enhance. So basically, they take an input function and then they give an output as a part function. So they don't give a part function, they just give the value. So what they do is they are usually used to add certain details or extract certain details from a bigger function. So let's actually just go through it, and it's a bit complex. If you write class neural net, okay, so this is my whole new class called class neural net. And in this, what we'll do is we will first initialize it, init underscore underscore. And what will this take? It'll take input layers and it'll take hidden layers, correct? And what will we do? We will put self dot input layers is equal to input layers, and the self dot. Oh, oopsie! I completely forgot. We were going to put the. Actually, you don't need to put self. You don't need to. I mean, okay, you do. Right. You know what? We can like rename these. It doesn't matter actually. Zero hidden layers. Okay. So now what we do is we usually use a decorator called property that basically transforms it slightly. So what does it take? This is, let's say, the input size property. So we're going to call it input size. What does it take in? It actually takes in an object, a functional object. So this is actually a functional object, and it will return self.input size. Okay, input size dot setter. Self.value self.input is equal to value. So that's an input size dot setter. So this is again a decorator. Okay. So now let's actually like instantiate this class. A class is basically a blueprint if you know basics of object-oriented programming. So let us create a new class. Create a new object from this class called we call this as object one, obj1, obj1 neural net. This is my name. So how will we initialize it? We will call it as neural net of around 10 and 20. I think that's a good number. Okay. So now we have created what do you call hidden layers, input layers inside this. But now let's say I want to get input size, right? So I can just state print object dot input size. When I do this with this property on, it's going to give me this. Now let's say I did not have this property, right? Let's say I did not have it. Let's say I say hidden size, okay? Let's say because this is to illustrate the difference of using the decorator and not using the decorator. And whoops, and you will see it right over here, okay? And okay, so we already know this dot input size is equal to 20. Okay, so what we can do, okay, so this is to show, this is the setter. So this is the input size dot setter. So these are all special properties. So the setter and this property are all special. Okay. I will give you an example now of this is a decorator, a setter decorator on top of the property of input size, right? We use them to make it easier to define and make classes in Python. Okay. So if we do this, we first instantiate it and then we print the object one.neuralnet.input size. We just print the input size. Okay. Now we will do very simply print dot hidden size, and you will see the difference between this and this, there will be significant difference. You just have a look. Okay, wait, there's a bug. Maximum recursion depth exceeded. Self.input size is equal to value. Okay. Trace back. Object 1 is equal to neural net 10, 20. Definition. Okay. At input size dot setter self comma value. Self dot input size is equal to value. Okay. I think this part was a bit wrong. I'm just going to comment it out for a moment and let's just run it. And that. Okay, sorry for the blurb again. Another small thing, you're supposed to always have an underscore. So if you recall, what I had done initially was I did self dot input size directly. But this is wrong. You're supposed to put it as an internal variable. That's the only way you will be able to save it within a class. Otherwise, you can't save it because you need to save it as an internal variable. So please remember to put underscore. Next error that I had done was I had actually put return self.input size. But if I were to do self.input size, this would call this function itself again and again and again and again. The whole point of calling this is to call this. So what you would do instead is you would always have to put this, right? So always remember to put the underscores for returning the actual value of the internal variables that are present there, right? That's basically what I wanted to know. So I think this sort of does wrap it up. Um, and yeah, I think we are ready to do tensors from now on. This was very preliminary. I also brushed up a few concepts that I had forgotten long back. But yeah, thanks for sticking along. Bye bye.